Hello everybody. In our previous video we talked about construction of LR1 items, and once we have constructed this, now we can create our canonical LR parsing table. So the process of constructing the canonical LR parsing table is very much similar to the way we have constructed the LR0 parsing table, SLR and LR0 parsing table. So let's see what we have. So the grammar that we are using is the same grammar that we have used earlier, for which we have constructed our items. So here I have, this is the grammar. This is the grammar, and we have already constructed the canonical set of items for this grammar, the LR1 items. Now with this we are going to construct the table. So the table is again the same. You have the states. For each state you have one row. So here I have 10 states, so I have I0. Let me write 0, 1 instead of I0 and so on. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I have 10 states, and I have the action part. In the action part and the go to part I have. So in the action part I will have one column for each terminal symbol and one for our dollar. That is the one here for our dollar. Difficult to write it because of lack of space. Okay, let me just bring down this line a little bit. Okay, so dollar. And here I have the variables. In the go to part I have S and C. So the shift part is the same. That is, if I have suppose, let's say I have a item like this, alpha dot A, beta and B is the look ahead. So if I have this in my collection, I, okay, then go to I on A would be suppose J. Suppose from here on A, I1 on A goes to IJ. In that case, I will have shift on A. I would have shift to J. Shift J. That would be my action. So this is exactly same as how we had done for our SLR parsing table construction. So in our states, here I have on small c, I have I0 goes to I2. Okay, and so here for C I will give I0 on small c will shift to I2. This is I3, so shift 3. I0 on C will be shift 3. Similarly, I0 on D will shift to I4. But will it be shift? Yes, we'll put a shift here. So this will be I0 on D will shift to 4. So I0 on D will shift to 4. Then I have 0 on C goes to here. I0 on S goes to I1 and on C goes to I2. So this part here, this will be 1 and this will be 2. Same for now for all the, let me put all the shift moves, then we'll go to the reduce moves. So this is the table after I have already filled up all the shift moves in the similar manner. This is exactly same as your LR 0. Now let us see the reduce moves. So if a particular state, say I, contains an item like this, a final item, that is alpha dot A, okay, and A is not the augmented production or augmented variable. A is not this. In that case, we will put in the action part on state I on A. Okay, because why A? Because A is the look ahead. So only in the column for A we will give reduce by A derives alpha. Reduce by A derives alpha. So if you can recall, in LR0 parsing table, we filled up, whenever there for every final item, we filled up all the columns with reduce move. In case of SLR, only the ones which are in follow of A. We filled up only those columns in reduce with reduce moves, only for those which are in the follow of A. Now we are not doing for everything, we are not doing even for the follow, but we are taking the one which are in the look ahead. So only for the, if the final item is for the look ahead symbol A, only then for column A we are going to put a reduce move. So if we again we number these productions, so if this is 1, this is 2 and this is 3, okay, so for I4 is a final state and its look ahead is it relates to the production number 3 and the look ahead is C and D. So we'll write reduce for I state 4, we'll write reduce 3 for C and D. So reduce for state 4, reduce 3 for only for C and D. Reduce 3, reduce 3. We'll not write for anything else. Only for the look ahead. Same way, this is one final item. Then next I have final item here. So S, this is our production number 1. Production number 1 according to our naming here. So 5, I5 would be reduce 1 for only dollar. So for state 5 would be reduce 1 only under dollar column. Then again another final item is this one, I7. Again this is also reduce 3 but for dollar. So reduce 3 under dollar for I7. So reduce 3. And then what else do we have? We have, this is our final item. This is production number 2. So production number 2 on state 8, we will put reduce moves under C and D. So 8, reduce 2, reduce 2 under C and D only. And finally, the last item I9. So 9 would be again reduce 2 but under dollar. So reduce 2 under reduce 2 under dollar. Okay, so the reduce moves, we are now restricting it only to the symbols that appear in the look ahead for that particular final item. Now what happens, when do we accept? We will accept when the final item is for the augmented grammar symbol. So our augmented grammar symbol was S dash. So this is the final, I1 is the final item for, this is the final item for this. So we will write except under dollar, under state I1. So I1 under dollar except. So this is your LR1, or how we call it, the canonical LR, CLR parsing table construction. Now the construction of the parsing table for the next algorithm, that is LALR, is again quite similar. You don't have to construct the items anymore, but the way in which the table is constructed is slightly different again. So as we are coming to, as we are learning more algorithms, we'll find that each one of these algorithms are more powerful than the previous one. So CLR is more powerful than SLR. SLR is more powerful than LR0. Okay, and LALR is more powerful than CLR. So we will see that in the next few videos.